polynomial equations, that's what we're talking about in this section. The goal is to solve polynomial equations and applications of polynomial equations. So today, we're not going to look at apps. We're just going to look at, well, how do we solve polynomial equations? And the fundamental rule we use is called the zero product rule. The zero product rule says this. You take two numbers, and it's always weird when we call the numbers letters, but say A is some number and B is some number. You take two numbers and you multiply them together. The zero product rule says if A times B equals 0, if some number A times some number B equals 0, what has to be true about at least one of them?
It equals 0.
Yeah, either A or B has to be equal to 0. So if A times B equals 0, then either A equals 0 or B equals 0. It's automatic, right? That's the only way you can get a product of 0. That's why we call it the zero product rule. Your book calls it the principle of zero products. Same idea. So now, what have we been talking about for the last, I don't know, it seems like forever. We've been talking about factoring almost the whole chapter, right? And what have we got over here on the left side of this part of the zero product rule? We've got a factorization, right? A times B is a product. It's a factorization of some number. So the idea is this then. If we have a polynomial equation where we can get 0 on one side and factor the other side, then we can set the individual factors equal to 0 and solve. That's what the zero product rule tells us. And so that's what we're going to study today. Example, solve in part A, it's already factored. It's already set equal to 0 and factored. It has to be both, not just factored, but also you have to have 0 on one side. So you have x plus 3 as a quantity times x minus 7 as a quantity equal to 0. So what has to be true about one of those factors? So I wouldn't normally write this down, but this guy is like the A from the zero product rule. This guy is like the B from the zero product rule. So what has to be true about one of those factors? So just set them both equal to 0 and solve to find all the possible solutions. So the idea is to set x plus 3 equal to 0. So either x plus 3 equals 0, either A equals 0, or x minus 7, B equals 0. And those are both linear equations. You know how to solve both of those individually, right? So if x plus 3 equals 0, what does x equal? Subtract 3 from both sides, x equals negative 3. If x minus 7 equals 0, what does x equal? Add 7 to both sides. Here's your two solutions. Can you check your answers? Absolutely. Look, if you plug negative 3 in for x, this whole term, or this whole factor rather, negative 3 plus 3 is 0, right? 0 times, okay, you got to plug in negative 3 for both of them, but does this one matter at this point? If this whole term is 0 when you plug in negative 3, I guess you get negative 10 here. It doesn't matter. You get 0 times whatever equals 0. It's a true statement. Or if you plug in, instead of plugging in negative 3, if you plug in positive 7, this whole factor, 7 minus 7, zeroes out. So you get, okay, 7 plus 3 times the whole quantity times 0, you get 0. It's a true statement. Your answer checks. You can always check your answers when you solve equations. All right, do you think they'll always be that easy? No, they're not going to be factored for you in general. So what if you had something like this in part B? 6t squared equals 8t. Okay, there's going to be a first step. Before you can factor, you have to set it equal to 0. And I'll write these steps down in a few minutes. But before you can factor, you have to set equal to 0. So what's an easy way to get 0 on one side, everything else on the other side? Yeah, I would do that too. Minus 8t, subtract 8t from both sides. And you get 6t squared minus 8t equals 0. Now okay, we don't have a product yet. In order to use the zero product rule, we have to have a product. So we factor. That's how we get products. So what can I factor out of the left side? 2t. And that's the GCF, right? Of 6t squared minus 8t. What's left? 3t minus 4. Can you check your factorization? Multiply it back out. 2t times 3t is 6t squared. 2t distributed over a minus 4 is minus 8t. Now, what does the zero product rule say you can do with both factors? So here's one factor. You set both factors equal to 0. So 2t equals 0. If that product equals 0, then either the first factor, 2t equals 0, or the second factor, 3t minus 4 equals 0. That's the zero product rule. And the idea is you solve those two simpler equations, right? Those two simpler equations they're simpler than the one we started with. And it contains both solutions to the one we started with. So, okay, if 2t equals 0, what does t have to equal? You could think of it as dividing both sides by 2. You don't have to, though. If you just think about it, t would have to be 0. If 2t equals 0, t would have to be 0. If 3t minus 4 equals 0, what could you do to both sides? Add 4. So add 4 to both sides. Get 3t equals 4. Divide both sides by 3. What does t have to equal? So either t equals 0 or t equals 4/3. All right, let's develop some steps here, you guys. And in fact, let me use this last problem as a model for our steps. Steps in solving a polynomial equation. So what did we have to do first? Yeah, these are guidelines, right? There might be some weird problem where you have to multiply it out first in order to set it equal to 0, so keep that in mind. This is a general guideline. Eventually, you might have to do something first, but eventually you want to set the equation equal to 0. Isn't that what we did when we subtracted 8t from both sides? Yeah, you bet. Okay. And then what did we do? So that was this step right here, where we set it equal to 0. And then what did we do? So if you look down here, this would be what we did next. To get from here to here, what did we do? We factored. Yeah, so you factor. Obviously, you're factoring the non-zero side, right? And then what do? What did we do in step 3 with both of those factors? There's step 3. We set them equal to 0. Now, that's the zero product rule, isn't it? That says we can do that. So apply ZPR, zero product rule, which means set factors equal to 0. And that's exactly what we did. And then what did we do after we set the factors equal to 0? To get from here to here, we solved those individual equations, right? So solve. And let's add a fifth and final step, check. Check your answer. Now, if you want to live on the wild side, you don't have to do step 5, I guess, right? But if you have time on a test and you have a good calculator, why not check it? Make sure you got it right. Now, that said, I don't have time to check them all in here. So when you see me not checking it, it's for time purposes to get through more examples.